Everybody, it's Eugene here. Today what I'm going to be doing is a very quick demo of the Polyga L6 Scanner. And that's this guy right here, just this black box. So this is a structured light scanner, and it's a metrology grade scanner. So it's not a handheld device that you kind of move around. It's a stationary device, and it's meant for high accuracy. So what I have set up here is just a little shoe on a turntable, and what I can do here is just show you how we can get some scans out of this. But I'm going to do this rather quickly, and the reason is that I did a full interview with Thomas Tong, who is the founder of Polyga, and so I want to leave some time for that. So this is going to be really quick, and then I'm going to jump into the interview. So let me get started on this. Okay, so first things first, I'm going to grab my notes here and tell you about this scanner. It's a compact structured light scanner, and like all structured light scanners, it has a projector. I'm not sure if you can see that on my hand, but there is like a fringe pattern that comes out and gets projected here. And then there's two cameras, okay? So there's one left and one right, and you have some redundancy, and it improves the accuracy when you have more than one camera. So this particular scanner is meant for scanning objects that are on the order of about 20 centimeters to about 1 meter. And it has 3 megapixel cameras, and also it has an accuracy of about 80 microns. The standoff distance, so that's the distance, from about the lens to the cameras to about the object, is about 68 centimeters, and it has about a 30 centimeter depth of field. So if I move this too close or I move it too far away, I'm not going to get any data at all. I have to be within that depth of field, that optimal distance. So setting this up properly is very, very important. So what I have set up here is just a shoe. And what I'm going to do is just give a really, really quick demo of how you could scan something like this. And I don't know, I can put it on its side or whatever. But give me a second here. What I'm going to do is I'm going to get the software going, record my screen, and then this way I'll show you the software as well. Just really quickly. Stand by. Okay, so I got everything pretty much set up, and we're going to focus in on the software here. So this is FlexScan, and it's a pretty comprehensive software package, but it doesn't have a lot of bells and whistles, but it does the basics well. It does everything that you need. So if you have to do multiple scans, or I've got a turntable here, I can take multiple scans and then piece them together. I can do that. It has editing functions. It has a number of different things that you can do. When you're scanning, you can scan points, you can scan meshes, you can capture color, or if you don't want color, you can do that too. So let me just have a look here, and we're going to just go through really quickly. So one of the tricky things with the FlexScan system or the Polyga system is actually setting it up. So it uses a network cable, and you have to plug that into your Ethernet adapter or whatever, and then kind of get going. So sometimes it's a little bit tricky. I have a problem with my antivirus, so I have to shut it off in order to get this to work. But no big deal. I got it going, and it looks like it's okay. So you'll see in the viewport here, as I rotate the turntable, okay, you can see that it's updating inside of the view here. And over here, this is really my scan settings that I'm looking at. So right now it's saying it's going to generate a mesh. I can also do points. Okay, I can also do alignment. So if I'm going to be registering one after the other, I can do that. I'm not going to show it for this video, but just know that it's there. You have a choice of cleanup. So you can choose none. So basically keep all the points relaxed, or you can just keep the best points possible. So I'll just go to standard right now, leave it like that. There's some smoothing, I can get rid of that if I want. Mesh density, and there's also texture capture. So I'll leave that on for now, no big deal. In other words, the other important one down here is going to be HDR. So HDR is kind of cool because if you have an object like this where you have light and dark, or something like this where it starts to get dark and light, you may want to capture it through a range of exposures, and that's really, really important. So I'm just going to do the sole here, but you'll see what happens here when I start making some adjustments. If I put the bottom end of the exposure up to 25, you see everything went red, so it's too much. Okay, so I'm saturating it too much. If I go really, really high here, everything just goes red. Okay, so I'm not going to get too much. What I want to do actually is be on the low end, so I want to be about 5. You see I got a little bit of blue, and I want to be a little bit on the high end. This is kind of how I do it. I've got a little bit of red, so it's going to be a little bit overexposed. I'll probably go down a little bit. So here, I don't have any blues or reds, maybe a little bit, just tiny bits. So this should be able to pick everything up well. Okay, so I'm just going to go ahead and click on scan. And you can see the pattern here flashing. So if I had a whole number of exposures, like if I went from 5 to 100, then it would be taking multiple scans over and over and then basically combining them all. And there you have it. You see that I've got a scan here. You can rotate this around. Like I said, there's a number of things you can do. So for example, there's like a cropping plane if I want to get rid of the turntable and the table and things like that. A whole number of features. But I didn't want to make this into a long video because I've got the interview that I gotta basically do here. So what I'm going to do is I'm going to pause here. This gives you a quick idea of what FlexScan is and how it works. It's a cool system. They're priced really well and they give good quality data too. But let's go to the interview now with Thomas Tong and we'll move on from there. Hey Thomas, thanks so much for being here today. Really appreciate your time.
No, thanks so much for inviting me, Eugene. Glad
All right. Hey, well, I want to ask you first about you. And you've been around for some time in this 3D industry. And just very quickly, how did you get started in all of this?
I was actually got into 3D, this particular 3D scanning industry about 10 years ago. I was in the video game business, making video games for about 10 years. And I did a whole bunch of 3D scanning and making video games for about 10 years. And then we were paying a lot of 3D scanning services and kind of on a bet whether I can make a 3D scanner. I took a bet on somebody whether I could do it over a weekend. I totally lost the bet, but I did end up making a 3D scanner. So about 10 years ago, I started a 3D scanning business and around building FlexScan 3D as a kind of a DIY sort of build your own scanner solution. So I built up a 3D scanning business around that. And then I sold that business 5 years ago. And then I took a couple of years off and I was intending never to do 3D scanning again. But a friend kind of asked me to help him out with some reverse engineering, some scanning stuff. And kind of a lot of different events transpired and ended up me being back in the 3D scanning business again. So these days I run Polyga and we build structure like 3D scanners and we build software to do useful stuff with 3D scan data.
So hold on a sec. I got to back up now. So you were in the 3D gaming industry. So what was your role back in the 3D game? Were you like modeling assets, or what were you doing?
No, I was a software. I was a mix of programmer. So I did all sorts of programming. I did network programming. I did AI programming. I did graphics programming. And I think the first game I ever worked on was a PlayStation 1 game. So actually, my name is on the credits. I did a ESPN Pro Borders, and that was a PlayStation. PlayStation 1 snowboarding game for like Fox Sports at the time.
Oh, wow. That's amazing. So when you embarked on this new journey of yours, I mean, was like the metrology grade scanners is really what you were sort of interested in? Is that, I mean, you obviously have a range of scanners, but who was, sort of like some of your main clients or customers?
Yeah, so I would say we our scanners aren't quite target for the hobbyist. We do a little bit of that, but I think most of our targets are researchers. We do metrology inspection. We do medical inspection. But I think the common thread for our customers is we tend to sell to engineers, right? People who need a certain quality of scanner that needs to work in industrial environment. They need accuracy that they can trust and depend on, and they need performance, and they need access to SDKs, and they need access to work with other kind of I would say other engineers that can help them answer the questions and solve their problems. So that's kind of our target, I would say, group that we build equipment for.
Okay. And I mean, I noticed that you have like a pretty wide range of different types of scanners. And let me see if I go down. So like you have like smaller versions. You have like industrial scanning large objects. Affordable too. Yeah, I like that one. You can call one affordable, a new one.
Affordable if you're a small business, I think,
right,
or
right.
a rich individual, it works out for. But we love working with everybody.
So in terms of the structured light scanner, I've noticed like I don't know if all the scanners are sort of based on a similar technology for you, or if you change it up in some cases, but can you talk about the different types of technologies you have in some of the scanners? Like you have the compact, and then you've got the other one that has like the oh boy, the carbon, I think it's called. It's like a,
Yeah. So it's a little bit confusing, and we probably did a terrible job naming things, starting with the letter C for both. But the high level idea is the carbon is an adjustable field of view scanner, and I think these tend to be I would say the old school style of structure light 3D scanners, which have been around for quite a while, whether it's from us or a German company or some other company, where you have variable field of views, right? You have the machine vision cameras on the outside, you have the projector there. And the good thing about the carbons is they are adjustable field of view, so you can move the cameras closer and further apart, and you can do auto calibration yourself to figure out, to kind of dial in the system to the exact field of view that you want to scan, right? And then we have two versions of carbon, one bigger, one smaller, depending on what it is that you go for. I think mostly these days people buy from us the compact series, because honestly, I think new people into the space, they don't want to deal with the complexities of calibration and setup and configuration. So the compact is called you kind of figure out what field of view you want. You buy the unit, you plug it in, and it kind of works. And both the carbon and our compacts and then the handheld scanners use the same kind of structure light scanner technology. I mean, they have different cameras and different projectors and wavelengths and all that kind of stuff. But by and large, we use the same sort of structure light scanning methodology that's kind of been, I would say, a benchmark in the measurement industry, which is using a combination of binary and phase patterns to generate high accuracy 3D.
Okay. What's important about the relationship between the camera and the projector? For example, how close they are or how far apart they are, and when you add an additional camera?
Yeah, so the way structure light scanning works is you have to project a bunch of patterns onto the surface of the object. And what you do is the two cameras essentially do triangulation. And I think, on your program, you talk a lot about photogrammetry and active stereo and passive stereo. And structure light scanning is essentially a form of active stereo triangulation, right? So in passive stereo, you kind of do stereo triangulation using what's, existing, using the textures and what you see out there in the world, right? Same with photogrammetry, you're using whatever you see it is on the world. You have active stereo where you project some sort of noise pattern to aid in that triangulation. And with structured light, you essentially use a series of patterns to project a very accurate pattern on there. So you have exact pixel correspondence to your two serial cameras. So in terms of the position of the cameras and the projectors, really, you need an overlap between the projector and the two cameras to get data. So you can kind of think about it as three triangles all coming out of the camera and the projector, and the overlap of the three is where you get data. To directly answer your question, what's the how do we determine what angle and what position put the camera as? Really, generally what you do, you can think about it is the more triangulation angle you have, you tend to have more accuracy, right? Because you can kind of think about lines of triangulation. If they were parallel, a little bit of pixel drift gives you a big jump in measurement detail, right? But if you get the cameras, essentially, when you put the cameras closer together, you can see deeper, you can see more data, but you get less accuracy. And you put the cameras further apart with a more angle, you get more accuracy, but you get less coverage.
Okay. Well, so the scale of the object will matter at that point, right? So if you have a camera very close to the projector, then you're sort of limited in the field of view and sort of how large the object can be. Does that make sense?
Yeah, absolutely.
Okay. And you also mentioned the wavelength, and I was curious about what you can tell us regarding the choice of light that you use to project on different objects. What are some of the advantages and disadvantages of choosing different wavelengths?
Yeah, by and large, there's at least in the industry out there, you have a lot of white light scanners and blue light scanners and whatnot. Generally for most, I would say 99% of the applications, it really doesn't matter what wavelength you choose. Effectively, the reflectivity of light just behaves pretty similarly between blue, green, red, or whatever wavelength of light. Generally, the wavelength actually matters more when people want a visible scanning system or IR type scanning system. So if you're scanning something's face, sometimes people want IR wavelength, because then you don't have bright lights flashing in someone's face, right? And definitely going blue light is interesting for kind of being able to filter out ambient light as well too. So I think just depending on which environment that you're working with, choosing a wavelength of light matters. But actually what we found is actually for 95% of our customers, what light choice to use isn't really defining factor of what it is that they're looking for whatever scanner it is that they need to use. Usually it's some other parameter.
Yeah, sure. They just want the scan. They don't care what light what lighting you're using.
And usually it really doesn't matter. And there's a couple little particulars that why we kind of choose one, color sometimes or one wavelength either over the other. But usually for us, it's more for either commercial purposes or marketing purposes, right? Like if all of our competitors are using a blue light, which has been a really kind of common marketing kind of term around it, then we're kind of forced to like, well, I guess if they're all using it, we better use it too. But in our test, using blue, red, green is almost nearly identical.
Yeah. Now the software it's Flex Scan, right? So
yeah, it's Flex Scan. Yeah.
Okay. So and that's something that you started like from the ground up.
Yeah. So that software is taking quite the journey. So 10 years ago, we sold it as kind of like a hobbyist product, sort of like the David scanners. I'm not sure if you're familiar with those, but
I am.
Yeah. So we sold that maybe 10 years ago as a precursor. Like we started before the David guys, I think, and we sold that as a kind of like a DIY type of system, and we did that for a number of years. But then we then we really transitioned to focus on the industrial space and less the hobbyist space. So we still sell that time to time for kind of DIY type applications, but not very much, because invariably what ends up happening for us is we sell like DIY type systems, and then people want to know everything about how to build a scanner, and then it goes into all of our kind of trade secrets, and then they're like, hey, can you give us drawings and teach us how to build a scanner? And while as a tech guy, I'd love to share all that stuff, but at the same time it's like, man, I just spent a ton of money buying projectors and cameras to figure out this problem, and as much as I want to tell you, it's not practical for us to run a business that way sometimes. So
yeah. Well, I've noticed the software is relatively easy to use, but it really has one focus, which is getting the scans together, scanning, and then getting the scans together if you have to do some level of registration or combining some of the scans. So it's pretty dedicated to the basic functions that you would need in a scanner. Does that make sense?
Yeah, absolutely. That's the full goal of the scanner, which is to help you, calibrate your scanners and just acquire scan data and get into a full 3D model. We do have some extended functionality in there for you to do some basic mesh to mesh deviation. You can do some, primitives and some measurements off of it, and you maybe change the coordinate systems of your meshes so that they're grounded and centered the way you want. But I think 95% of our customers use it to generate a clean watertight mesh.
Have you, I'm just curious about your customers. I mean, you mentioned there's a lot of engineering type of customers you have, but in the recent, 5-10 years, maybe there's been a lot of work now with augmented reality, VR and stuff like that. Are you seeing maybe more people that are interested in creating like small objects more for visualization or for presentation of virtual reality and augmented reality?
Yeah, we do see it, and I've actually seen various waves of this over the last 10 years of people. 5 or 6 years ago, it was all these people wanting to scan and 3D print. These days, there's a lot of people wanting to scan and put it into AR, VR. And for me, I come from a visualization video game space, funny enough, and I think for doing AR, VR, it's still the case that a lot of times it's easier to hand create something. Really the scanners, where the scanners are strong, or structure light scanners are strong, is to capture high resolution geometry. And usually for AR, VR, really what you want is high resolution texture. So I really think photogrammetry is a better solution for AR, VR type stuff. It's a better solution for visualization photogrammetry directly, because you don't really care that much about the geometry. You do, but I mean, you're going to decimate, it's going to be low geometry. And if you get high resolution geometry, you're going to bake it into a bump map or some sort of offset map anyway, or bake it into your texture map. So it doesn't really take advantages of what's strong with a structured light scanner, which is you get really high accuracy geometry and you get it fast. Where photogrammetry, you kind of do photogrammetry and you hope, you wait and you process the data and you get good data down the road. With structured light, we can get the complete data, the complete mesh in hundreds of milliseconds, and
right.
You can process it. So really for structured light, at least our type of tech, it's more useful, I think, for like machine vision or applications where you need high accuracy data fast so you can take an action.
Yeah, no, that makes sense. I mean, a lot of the, like, for example, some of the iPhone apps and things that we're seeing right now, they look great, but they are not accurate. So a lot of the things that are fast with the phone is usually not great accuracy, but hey, it looks cool because it's got a nice texture on it or something. So it kind of tricks your eye into believing it's more accurate or more true than it actually is. What about you have a handheld scanner as well. Is
We
that
do.
relatively new?
Yeah. We're new in the handheld market, so I think our strength traditionally has been in our stationary products and for doing robot vision and all that kind of stuff I just talked about. So, but the world likes handhelds, and we agree with that. They're really cool scanners and they're really useful. But traditionally, handhelds haven't been that particularly accurate. So we put our first foray into our handheld device, H3, about a year and just before COVID started. So maybe it's not so new anymore. So that's our first kind of stab at handheld. I think it's a pretty cool unit. The big difference between our handheld and other handhelds is it's a full structure light handheld. So most handhelds are what I call active stereo. They're single shot. They just project a noise pattern on, and they get really low resolution data. So the H3 is our kind of first step at a structure light handheld. So it actually does like all 15 patterns to get the data. The resolutions of the cameras are relatively low right now, but we are planning to do new versions of the handheld that can maybe showcase our particular take on this technology better in the future.
Oh, that's pretty interesting. So when you say it that way, because when I see it mounted on the tripod there, I'm like, hey, it just looks like you turn it sideways, it looks like a structure light scanner, but really there's just a handle on the back. So yeah, so you can scan. So you obviously have to be able to project these patterns extremely quickly, right? Because you have to minimize the movement between the position of the object, because all the other ones are sitting on a tripod, so it doesn't matter how long you take. But in this case, did you have to do anything to the pattern or to the wavelength of light or anything like that to accommodate for movement?
Yeah, we shortened the patterns, so it's a different sequence of patterns, but it is still, I think this one's like a 13, 14 pattern sequence still. So that's the one big difference between our handheld and I think almost all the other handhelds out there, that we're doing that full structure light sequence to gather data. The end result that we're getting right now is better. I think it's better than most of the competitors out there, but we're missing a lot of the other features they have because it's our first stab at the product.
Mm-hmm.
It's the first time out. But like you said, it is. I think the big interesting part for that unit, and anybody who's ever curious in handheld, is that we do have a little bit more runway than the other technologies in terms of if we can put in a more high resolution, high speed cameras into the unit, we'll be able to capture essentially handheld structure light scan data quality. And I think you've been playing some of our scanners, and you can kind of see the big difference between what you can get from, let's say, structure light versus LiDAR or active stereo or something like that.
Yeah. So what can you tell me about the future and where you guys are looking at? Are you looking to, and you mentioned that potentially there could be a newer handheld scanner coming out or whatever, but is there anything else you can talk about at this point that might be interesting for some people?
Yeah, I think our next product release is we're switching over a lot of our products from Gigi. It doesn't sound very exciting, but actually it's a whole ton of work for us internally. But we're switching over from Gigi to USB, so it just makes people's lives a lot easier to connect. But we have a side effect of that doubles our bandwidth, so our scanning speed is doubled. So our handheld scanning speed will double, all of our product scanning speed will double. So I think that's one of the big things that we're coming out with in the short term, which is a transition from our Gigi products to USB line of products. We have a second product coming out similar to the S1. I'm not sure, to the S1, called the V1, which is going to be a computer vision sensor. So the way I kind of talk to people is traditionally in this market, we think of 3D scanners as 3D scanners. But, as these things become a little bit more, I would say, ubiquitous and things are moving out there, I think a better term for it is just literally 3D cameras. Right. At the end of the day, we're building 3D cameras, and the underlying technology, whether it's LiDAR, various forms of stereo, or our structure light, I don't think the end consumers care. So they just, at the end of the day, it's some sort of pseudo 3D camera. So we have a new product coming out called the V1. And what it is it's kind of like in the compact kind of form factor you saw, like a big metal box. But we're selling it as a 15 FPS 3D camera, effectively. That's going to give you high resolution 3D scan data that you can kind of use as a 3D camera, and it's going to be targeted for people doing computer vision research, people who want to do robotic guidance, or even medical imaging, so that you can have especially a high-speed 3D camera just dumping out point clouds at X FPS for you.
Okay, wow, that's pretty exciting. That is super cool. Is it something that potentially you could use to record? I don't know what kind of resolution you're talking about, but is it something that you could use to record motion, for example, like somebody at 15 frames per second, something moving or anything like that?
Yeah, absolutely. That's our goal, so that you would be able to record some level of motion. So it's not the problem we have right now on I think the 3D camera space is almost every product out in the market right now is very low resolution. So, I don't think in the last 5 or 6 years we've gotten anything appreciably better than the original Kinect. So we have
Hmm.
different variations of the Kinect with the RealSense and new lidars from all the different phones and stuff like that. So really, we're trying to kind of put out a high resolution 3D video camera. Is
Oh,
what
that's
our goal
amazing.
is. Yeah, but the field
Well,
of view is targeted to be relatively small, around 200 about 200 field of view. So it's a little bit smaller. But we figured like almost every other kind of, I guess, Kinect style sensor right now is coming out at several meter field of view, and we haven't had any products that are small field of views that you could use for, say, tracking fingers or tracking facial motion or anything like that.
yeah, that's amazing. That's a great idea. So I'll be interested to see what you can do there. Awesome. Well, look, Thomas, thank you so much. I really appreciate your time. Interesting products. I know we have been, in fact, using it for a footwear impression project and using it with success. And I'm going to be looking at some other things that we can do with this in the meantime. But hey, thank you so much for your time.
Thanks for bringing me out again.
All right. Cheers. Bye-bye.
Yeah, thanks, Jim. Bye.